Now that we've addressed the inside of our polygons, we can start looking at the outside of our polygons and figuring out how to measure the outside of our polygons. An important fact is that the outside of our polygons, all exterior angles of a polygon sum to 360 degrees. So that's any polygon. Our exterior angles are going to sum to 360 degrees. So below we've got a triangle here. And the way that we could prove that is because we could extend these segments of our triangle out just like these are. And we could measure like angle X here. And that angle would be a linear pair, or two angles that add up to 180 degrees and are adjacent to each other. So that would be a linear pair with here. So if we knew the inside of this angle, we could solve for x. And if we added x and we added z and we added y, then that would give us a total of 360 degrees. Or if we knew parts of it, we could solve for other parts of it. So basically, if we had, moving on to our next one, if we have a regular polygon, what it is it ends up becoming 360 degrees divided by n number of sides. So let's go over to this question here. Find the measure of one exterior angle, so it's asking for one exterior angle, of a regular hexagon. So a regular hexagon or a regular polygon means all the sides and all the angles are going to be equal or congruent. So they're all going to be the same. So in here, we can go straight over to a regular polygon, what we learned. Our regular polygon says we can take 360 degrees and divide that by 5. And when we do that, that's going to equal 72. So each of our angles here are going to be 72 degrees. So angle A here, 72, 72, 72, 72, and 72. And if we added those all back up together, we would find that it comes to 360 degrees. If it's not a regular hexagon, we would need to know some of the information of the inside of our polygon, or parts of our exterior and parts of our interior to solve it. Because if we knew angle A was, for instance, let's undo that. Let's give it a different color. If we knew that this was 60 degrees, well, we'd be able to know that the rest of this linear pair is 120 degrees. And we could solve for pieces that way if we knew some information here. But, like I said, because we know that this is a regular polygon, that all the sides and all the angles are going to be equal to each other. So we do not need to find the other information. We can just take 360, which is the sum of all exterior angles of any polygon, and divide it by n number of sides.